Hello,
Luke, how you doing?
I'm good. How are you?
Good. My name's Dave. Nice to meet you, even though it's
Nice
a
to meet
Zoom
you.
meet.
Yeah,
Yeah, Saturdays are for all I see is the boys. Okay.
yeah.
I was trying to figure out what was in front of the boys. The boys. All right, I got you. Um, so let's see what's going on. What's going on with the math? Are you having a little bit of trouble?
Yeah. I'm having a little bit of trouble with the SOHCAHTOA, like
Oh,
the
okay.
cosine tangent.
Yeah, I got
I'm,
you. And what grade are you in?
I'm in 10th.
10th grade. Okay. And how do you feel about math? Are you like you hate it, it's or you like it, or something
Uh,
else? I don't know. Give me something I haven't heard before.
like in the middle. Like I don't really like it that much.
You don't like it that much?
Yeah.
What do you like your favorite academic subject in school? Do you have one? I don't know if I ever had one,
Probably
to be honest with you.
maybe like chemistry.
Yeah,
Yeah, and history.
in history. Yeah, chemistry's got a little bit of math in it, like some algebra and stuff,
Yeah.
depending on what you're doing. Yeah. What else are you interested in? Anything else outside of the academic stuff?
Yeah, soccer.
Soccer? Are you on the school team?
No, I used to play on the school team.
Okay. What position?
I was left left back.
Left back. So is that defense?
Yeah.
So back is defense. Yeah, I used to. Let's see. The last school I was at, I don't teach anymore, but I announced all the varsity sports. So I learned a lot more about soccer than I knew because I never played soccer. I wasn't good enough, but I learned about it and really grew to appreciate it. Do you watch like the MLS or the
Yeah.
Premier League or anything like that?
Yeah, I watched some of the MLS games.
What's the team in LA?
Um, I'm not sure. I kind of forgot. I don't really
Well,
like pay too much attention to the teams, but
oh, okay. Well,
yeah.
we had I'm in Orlando. I don't know if your mom told you. I'm in the Orlando area, and we had um, Orlando City, I think the name is, and they they sold out a football stadium like 5 years ago, and now they're having trouble getting people to come. I hope we don't lose a team. I like having the teams around.
Uh,
So okay, all right. So let's see. Do you have homework or something you want to go over? You want me to help you with, or notes or anything
I don't
like
really
that?
have any homework right now.
No.
No.
Okay. And how long have you been doing the Sokotoa?
For like a little while, like 2 weeks maybe, something like
Two.
that.
So you've been having to find angle links and side links and all that
Yeah.
horrible stuff. Okay. All right. So how I usually work this, first of all, is you're the boss, you're the CEO of this whole thing. Okay.
Okay.
So whatever you're having trouble with is what we're working on. And it's not like a normal student teacher type thing where you might be hesitant to stop me from doing something or like you're free. And in fact, I want you to say, "Hey, Dave, I got it. Let's move on to something else." Or, "Hey, you're moving too fast. Don't be
Yeah.
shy." Right? Because this is, if I'm not helping you, then there's no point. Right?
Yeah.
So be sure and let me know. Okay.
Okay.
All right. So I can pull up plenty of Sokotoa practice. And what kind of calculator do you use in class?
Um, I use it's the Texas Instrument one,
The 84 or the Inspire 83?
the 30X.
Oh, 30XA?
Yeah.
Okay, I got you. Okay, CUDA software. Give me one sec. Oh, here we go. All right, we'll start. We'll just see where you're at. I'm gonna start with this stuff. I'm just talking to myself. Sorry.
That's okay.
I can. You'll see I'm a bit odd, Luke.
I think I can also like bring up some problems from like a review.
Okay, yeah, that would be great. That would like from a past review or something.
Yeah.
Do you have it online or something you can take a picture of and send me?
Yeah, I think I can.
Okay. If are you familiar with Zoom?
Yeah, a little bit, yeah.
Because you can share your screen and then I'll take a picture of it and put it up on the whiteboard that we're going to use.
Okay.
Is it like an online textbook?
It's just like a PDF.
Oh,
It
okay,
like uploads to our like classroom thing.
I got you. And how's your teacher? Do you understand what did you say he or she?
He,
He, do you understand what he's saying or you get along
yeah,
with him?
I understand what he's saying in class, but then like once I go home, I like kind of like forget how to do it.
Oh yeah,
Yeah.
happens to all of us. And when I was your age, I was an okay math student. It didn't make sense to me till college. It was really frustrating for me.
Should I just share my screen?
Yeah, share your screen and then I'll take some I can just take some pics of it.
Okay. I think that's it.
Oh, okay, cool. Just give me a sec and I'll do a thing here. Where'd it go? Oh, there it is. Okay. Again, talking to myself. All right. So I got through 17. Scroll down a bit and I'll get the rest of it. Was this like a full assignment here?
No,
The
I
whole
think we just did
page?
do like some of the problems. I think like 14 to 16.
14 to
I think like
16?
7 to 9. I
Okay.
think. Yeah.
All right. All right. That's a good place to start. Okay, so everything that we write that you see on this board, I will PDF and email to you, okay, when
Okay.
we're done. It's also being recorded, so you know, it's so riveting and exciting. I find that my students, they watch it over and over again. They don't do the Netflix or anything. They don't do the TikTok. They just watch their math tutoring sessions over and over. It's amazing the reaction that I
Yeah.
get. And I'm totally kidding, Luke. God, okay. Okay. So can you see the screen okay?
Yes.
Okay, so I just did it in different sections here. There we go. I also had just put some other stuff on there when I didn't think you had something. Okay, so you said like 7 through 9 and stuff,
Yeah, I think it was also like 1 through 6.
1 through 6. All right, so we'll start with 1 through 3. Let me do this. I'll send it to its own page. Oh, there it is. This is annoying. All right, there we go. So with the SOHCAHTOA, before we even do that, I just want to talk about the trig ratios real quick, because I think it's important to have an understanding of what's actually going on there. And the sad thing is, one sad thing is I didn't know this until like one of my last years in college, that this is why these, I thought it was just some magical thing. Maybe you already understand this part, maybe you don't, but we will see here. Okay, so so in a right triangle, and ignore the little guy for just a second. If we talk about an angle, and this is for a right triangle. If I talk about, I don't know, we'll call this A, we'll call this B, and we'll call this C. And let's just say that this is 6, this is 8, and this is 10. Okay.
Yeah.
And if we were to take the ratio, I'm just doing something on my calculator real quick. Let's just say this is a 37-degree angle right here. Okay. So okay. So for any 37-degree angle, if I start taking ratios of these sides, those ratios are constant no matter the size of the triangle. So we know the acronym SOHCAHTOA. And are you familiar with what all of the letters stand for? Are you okay with that?
Yeah, I understand it.
Okay, so I'm just going to go with tangent. Let's say we take the tangent of angle A, or the tangent of 37 degrees in this case. Do you agree that would equal 6/8?
Yeah.
Opposite over adjacent, which is the same as 3/4. And then the sine of 37, what would that be?
The sine of 37.
Yeah, just the ratio.
It's 6/10.
Good. And that simplifies to 3/5. Is that okay?
Yeah.
And then cosine of 37 would be,
Oh, cosine.
yeah,
And 8/10.
cool. So that's 4/5. Okay. So the point I want to make is no matter the size of the triangle, like I made a smaller triangle, but do you see how it's the exact same angle, 37 degrees?
Yeah.
And then if I moved it up here, this angle is the same up here, angle B.
Mm-hmm.
Right? Okay, so I'm going to put this guy here. So no matter the size of the triangle, the ratios, I'll just say P, Q, R here. If I took the sine or the tangent of P here, it's still going to equal 3/4. Right? It's the ratio of the opposite side to the adjacent side. So no matter if this is a ginormous triangle, if I take the opposite side divided by the adjacent side of a 37-degree angle, it is always going to be, why did I say, oh no, that's cosine, 3/4. Does that make sense to you?
Yeah.
Okay. And so that's why the trigonometry is so powerful, is with those angles, the size does not matter. With those ratios, we can find lengths and heights, and you know, it's all done with computers nowadays, but that's some of what is done to make all kinds of different calculations. Okay, so just wanted to make sure you understood the ratio part before we continue here. So to solve the triangle, number one, I'm just going to redraw it so it's a little bit bigger for us. So solve means what? What the heck does that mean?
Like find the like number that t or s is gonna be.
Yep. And also to find the angle, right?
Yeah.
Oh, no, find the value of each variable. The other one,
Oh yeah.
all we have to do here is find the variable. Sorry, it was the other ones that said solve the triangle. All right, so which one would you like to solve for? S or T?
Probably t, I guess.
Okay. So all we know is the 25-degree angle. We could get this angle here if we wanted to, right?
Yeah.
And use that if we wanted to, but we might as well use what they give us. I always say that because just in case we do something silly and make an error, you know, calculating that angle, go ahead and use what they've got. So looking at that, do you know which trig function, looking at what we have, do you know which trig function we would use to solve, to help us solve for t?
It would be, wait,
And if you don't know, it's fine.
uh, cosine?
No, it would
Okay.
be sine. And the did you say S or T?
I said
I think
s
you
or
said,
t?
yeah. Yeah, did you say we were going to solve for S or T?
T.
Okay, all right. So what you have to do is, since we're solving for T, right? You have to look at what we have, what is given to us. And the angle 25 degrees, do you see that it is opposite
Yeah,
of T?
opposite. Sorry, I thought, I don't know why I thought adjacent. I knew it's
Oh,
opposite. I don't know why I thought adjacent.
happens to the best of us. And
Yeah.
18's of the hypotenuse, right?
Yeah.
All right, so you got pen and paper?
Yes, I do.
Okay, let's go ahead and solve for T. I'll do it silently and then we'll compare notes, okay?
Okay.
It'll be great fun, Luke. Nothing
Yeah.
better than mathematics on a Wednesday evening. And we'll just round to the nearest tenth, okay?
Okay. I have
What'd you get?
I got the like 7.6.
Cool, good. All right, so now we got T 7.6. What do we want to do about S?
Uh S. Wouldn't it be, yeah, it's wait. Yeah, it's cosine.
Excellent, excellent. So let's go ahead and do that one. How'd we do?
I got 16.3.
Sweet. Are you, do you write it out like I write it out, or are you sort of a neat writer or all over the page type thing with your math?
I'm like kind of like sometimes like me most of the time.
Okay, cool.
Yeah,
Can you, just so I can see, can you snap a picture? You got your phone with you?
I can just like put it up to the screen.
Okay, that's cool. Let me stop sharing so I can see it. Oh, so you can actually, you do a lot of it in your head. Okay, that's good. You can put it down.
Okay.
You do a lot of the algebra in your head,
Not really.
looks like.
Yeah,
Okay.
that's just how like we always write it out.
Okay, I see. Okay, so let me try, I do want to try number 2, actually. All right, so let's go ahead with number 2. And let me know which one you want to solve for first.
We can do Y.
Okay. If you're stuck, let me know.
I'm just kind of confused on Y because it's like right next to.
Okay. So we're going to use the 22-degree guy, right?
Yeah,
Okay. So with 22, what's the relationship to 6?
it's opposite.
Excellent. And which is the hypotenuse, X or Y?
X.
Cool. So that means Y has to be adjacent, right?
Mm-hmm.
Okay, so folks or students usually get confused between which one is the hypotenuse. You seem to have that down. So in relation to 22 degrees, and we want to solve for Y, we've got Y is adjacent and 6 is opposite. So which trig function uses opposite and adjacent?
Tangent.
Yep. So then the equation we would write would be what?
Tangent 22
Cool.
and wait, and then opposite over adjacent, so 6 over Y.
Cool. And then what the heck are we going to do to solve for Y?
I put like 1 over tangent 22, so it like goes together.
So you did, let me make sure I understood you right. So you did 1 over tan 22?
I mean under, sorry.
Oh, okay. I'm sorry. Okay,
Yeah,
I got you. Oh, okay. Oh, and then you do like a cross multiply thing?
yeah.
Oh, okay. That's a good strategy. Good. So Y tan 22 equals 6?
Yeah, and then you have to like isolate the variable, so you divide it by tangent 22 on each side.
Perfect. And off we go, right?
Yeah.
All right.
And then I got 14.9.
Nice. So we'll do X next, yeah?
Yeah.
Okay. It might help you if you just immediately write out the opposite adjacent and hypotenuse, but you have to make sure that you're doing it in relation to one of the angles, right? Like it doesn't work if we're talking about the other angle. Okay. All right, let's do this one on our own, and then we'll see if you get it. Okay.
Okay.
I'll hold back for a sec because I'm lazy.
Sorry, I got kind of confused on this one.
Okay. Did you pick out sine?
No, I didn't.
Okay. What'd you pick?
I just picked tangent again.
Okay. So we were solving for X, right?
Yeah.
Okay. So and we're going to use the 6. Yeah.
Yeah.
And 6 is opposite of 22, right?
Mm-hmm.
And we got to solve for X, and X is what?
Oh, hypotenuse.
Yeah. So that's why we got to go with sine, opposite and hypotenuse. Does that make sense to you?
Okay, yeah, that makes actually sense to me now. Because I
Okay.
was kind of confused on how to like find which one it was.
Okay. Well, hypotenuse is find which trig function it is, you mean?
Yeah.
Okay. Yeah, it's always in relation to the angle, right?
Yeah.
Okay. All right, go ahead and try and calculate it. I like the over 1 for cross multiplying. That's a good strategy.
Mm-hmm. Okay, I got it.
Got it?
I
Did
got
you get six? Go ahead.
16, yeah.
Sweet. Okay. All right. Let's go ahead and do number 3. So don't lie to me. This is the most fun you've had all day. Am I right?
Not really, but I need to know this.
Uh, Well, you know what, sad Luke, this is the most fun thing that I've done all day. How about that? That's
Yeah.
that's who you're dealing with over here, all right? Okay. So K and J. So I'm gonna go ahead and let's write out, or I'm sure you have SOHCAHTOA, or you have it in your head anyway, right?
Yeah.
So we're finding K and J, whatever, but they give us the 40 degrees, right?
Yeah.
So before we even start, let's just go ahead and label the sides as to what they are in relation to the 40. Probably should start with the hypotenuse, which is always opposite the right angle, right?
Yeah.
So that's J. So what is K in relation to 40 degrees?
Um, to 40, it's opposite.
Good. So let's just write opposite there. And so the 10 adjacent is next to, right?
Yeah.
So the 10 would be adjacent. And it seems to me you never get confused with what's the hypotenuse and what's adjacent. Is that correct?
I always know what the hypotenuse is, but I like mix up the adjacent and opposite.
What I always do, and actually I did when I was in high school with this nonsense, is I would just draw a line like sort of through the angle to show me which one is opposite. And then the other one has to be adjacent. Adjacent means next to, right? So it's like it's the one, it's the side that's touching the angle or forming the angle, and then the other one's always going to be the hypotenuse. So okay, so which one do you want to solve for first, K or J?
We can do K.
All right, so then you just look, all right, so that's opposite and adjacent that we're going to be using, right?
Yeah.
Okay, so then which trig function uses opposite and adjacent?
Tangent.
Did you say tangent?
Yeah.
Sorry, I got new AirPods. Yeah, so boom, right? So off we go. Tan 40 is K over 10.
I got 8.4.
Cool. I'm still here. I dropped something over here.
Yeah.
Okay, so what about J? Which trig function are we going to use to find J?
J is hypotenuse and adjacent.
Sweet.
So cosine.
There you go. A and H.
I got 13.
Yeah. 13.1, because the 5 rounds the 0 up to 1. Did you get 13.05?
Oh yeah, I didn't see that 0.5.
Yeah.
Yeah,
I mean, it just depends on what your teacher wants you to round it to.
yeah.
Oh, and I just realized I lied to you, Luke. I told you that this was the best part of my day. I forgot earlier today. I'm sitting at there's a window right in front of me, and sometimes a cat will come sit there. There was a bird out there. Every once in a while she forgets there's a window, and she went
Um,
after the bird. She's fine. Like, I'm not pro hurt the animals, but you know
yeah,
what I'm saying. It was pretty funny.
yeah.
I can't let my daughter hear that. She does not think it's funny. It's her cat. Okay.
Uh,
Um. Okay. I do want to let's take a look at this real quick. Because I think this will help you with the opposite, adjacent, and hypotenuse if we just do a couple of these. Let me, where's the thing? Okay. Actually, all right, so let's just take a look at this triangle. And we got our SOHCAHTOA going. Okay.
yeah.
And I'm going to ask you, what is the sine of x? What is the ratio for sine of x? And when I say x, I mean this angle x here.
Mm-hmm.
What would that be?
It would be the sine. It would be 21 over 35.
Close. You got the hypotenuse, right? So here's
Yeah.
x,
Oh, of
and I kind
x.
of, yeah. Oh, did
Yeah.
you? I think the direction said z. If you thought z, you're absolutely right.
Yeah.
Okay. Oh, that's cool. So x 28 is opposite, right? And 35 is hypotenuse. You okay with that?
Yeah.
Okay. What's the cosine of x?
The cosine.
Yeah.
X. It would be 21 over 35.
There you go.
Yeah.
Great. And then the tangent of x.
The tangent of x would be 28 over 21.
Excellent. Right. So now we're going to turn around and we're going to do it for z. Okay.
Yeah.
So sine of z would be what?
It would be 21 over 35.
All right. You know what you're doing. Cosine
Yeah.
z.
Cosine, it would be 28 over 35.
There you go. And so tan.
It would be 21 over 28.
Right. Do you kind of see the relationship? Now it's just
Yeah.
the inverse. Okay. All right. Good. All right. So you said 7, 8, 9 was a deal as well.
Yeah, it was also 4, 5, and 6.
Oh, okay. All right. So
I
what
know
do you
how to
know?
do, I know how
Go
to
ahead.
do 4, but I don't really like, I'm kind of confused about like the 5 and 6.
Okay. Well, how do you tell what kind of triangle it is?
When like the two smaller angles, you like, it's the square root of like what the number is. So you do like 16 times 16 plus 30
Uh-huh.
plus 30.
Right.
That's
Okay.
how,
So
yeah.
So 16 squared plus 30 squared, and you compare it, you take the two smaller ones and compare it to the larger one
Yeah.
squared. So we're using the Pythagorean theorem to figure this thing out, right?
Hmm.
Okay. And so, and it looks like they're putting them in order for us. So, for number 5, well, actually, let's figure this out just to satisfy my own curiosity. So 16 squared plus 30 squared, 16 squared is 256. And then 30 squared is 900. And 34 squared, I have no idea. I get 1156. 900 plus 256. Is that the same? Did you find out it's a right triangle?
Yeah, it's right.
Okay. So is your confusion that you know what it is if they're equal?
Yeah.
Okay, so that's a right triangle. Okay. So then you're okay with squaring 4 and squaring a square root?
Oh no, like on number 5, I'm confused about like the middle one.
Okay. I'm trying to see if I got a nice picture for you here. Okay. So are you able to tell how for the square root of 67, are you able to tell if its relationship between 4 and 9, like is it greater than 4? Is it less than 9 for sure? Are you able to do that without a calculator?
No, I'm just kind of confused on like what to do for it.
Okay, well, we have to get the two smallest ones, right?
Yeah.
Okay, and they do list them in order. They're being nice to us. But if they
Yeah.
didn't, we would have to be able to figure out where does the square root of 67 lie, right? Well, do you agree that 4 is equivalent to the square root of 16?
Yeah.
And 9 is equivalent to the square root of 81, right?
Yeah.
So the square root of 60, we now know square root of 67 is between 4 and 9
Yeah.
because it's in between their equivalent square roots. Okay. All right. So we just do the same thing, Luke. We do 4 squared plus square root of 67 squared, and we compare it to 9 squared. Okay. Are you allowed to use your calculator in class all the time?
Yeah.
Okay. So 4 squared is 16. Now, do you know in your head, do you know what the square root of 67 squared is?
No.
Okay. So let me just do something real quick. So if I took the square root of 5 times the square root of 5, would you agree that's equal to the square root of 25?
Yeah.
And the square root of 25 is what?
5.
5. Okay. Now that's no, the square root of 5 times the square root of 5 is the same as the square root of 5 squared, isn't it?
Yeah.
And it's equal to 5, right? Just
Yeah.
through this nonsense we did. So squared, and I'll just start it off like this, like, I don't know, the square root of 7 squared is the same thing as the square root of 7 times the square root of 7, which is square root of 49. Square root of 49 is
7.
7, right? So do you see the pattern here?
Yeah.
Yeah, the square root of anything, the square root of x, squared is equal to X. Doesn't matter what's in there. We were just square root of kitty cat squared is equal to kitty cat. Doesn't matter what's in there. Okay. It's actually easier. You know, square root of 67 squared is 67. Done. You can put it in your calculator too. And it'll give you that, right? But it's good to be able to just look at it and do it. And then 9 squared is 81. All right,
Yeah.
so then what do we have? 16, 83?
Yeah, 83.
Greater than 81. So do you know what that tells us?
It's a cube.
Good. So you know those rules, that's good. So your confusion was just with the square root thingy.
Yeah.
Okay, you want to try number 6 real quick? Just on your own?
Yeah. Yeah.
Okay. Is this 5.5?
Yeah, that's 5.5.
Okay.
I didn't know it had like a square root on the 5.5.
What do you mean?
On the picture, it didn't like show the
Oh, it didn't?
no.
Is it a square root
I think it
over
might
the
be.
5.5?
Here, I'll check. No, it's not.
I just
Oh
squared
no,
it.
it is. It is. Yeah.
So there's actually a square root right here, is what you're telling me.
Oh wait, no. Sorry, I
No?
just got confused. Yeah.
Oh, okay. No problem. So we're good?
Yeah.
Obtuse?
Yeah, I
Okay.
understand.
What does it mean for a triangle to be obtuse?
Um, it's like honestly, I don't really. It's like I'm not sure.
Okay. Do you know what an obtuse angle is?
Yeah,
What's that?
it's bigger than 90, and yeah, that's it.
And what's the last one? It's bigger than 90 and I think you wanted to say it. Less than 180.
Yeah, less than 180.
Okay. I knew you knew it just by the way you were about to say it. Okay. So in a triangle, right? The sum is 180 degrees, correct?
Yeah,
Okay. So I'm going to draw an obtuse triangle. Let's just say it like that. And let's just say the obtuse angle, it's the one that opens greater than 90 degrees. So let's just say this is 120 degrees, right?
yeah,
So there's only 60 degrees left, right?
yeah,
Okay. So an obtuse triangle just has one angle that's obtuse. That's all that's possible. Because if one angle is obtuse, the other angles have to be acute. They have to be less than 90. So it could be, I don't know, 20 and 30 maybe. Adds up to 180, right?
yeah,
So an obtuse triangle has one obtuse angle. It has a side that opens greater than 90, right?
yeah,
And so then an acute triangle would just have all angles that are all acute, right?
yeah,
Which is between 0 and 90. Is that right?
yeah. It is.
Okay. So I don't know, maybe 30, 70, that's 100, and then 80, whatever. So that'd be like an acute triangle. Okay.
Yeah.
Okay. All right. So let's take a look at this awesomeness here on this page. Are you okay with drawing your own triangle if you have to, like if they don't give you the drawing?
No, I don't think he's like listed those.
Oh, we didn't
As
do those?
yeah.
Okay. And have you had to find an angle yet? Like the
Yeah, I
missing
think so.
angle in a triangle
Yeah.
using trig, not subtracting from 180 or whatever.
Yeah.
Okay, so you've done the inverse trig functions.
Yeah.
Okay. All right. So let's see. Let's do number 7. Yeah, let's try number 7. Maybe that's how we'll wrap it up. And this one is solving the triangle, so we got to find freaking everything, right?
Yeah.
Okay. So what would we got to find what side AC, angle A, and angle C, right?
Yeah.
So what would we got to do, let's just list it. So AC, right? And then the measure of angle A, we got to find. And then the measure of angle C, we've got to find. And our good friend SOHCAHTOA. So what do you want to find first?
We can find AC.
Okay. And how do you want to do that?
Um AC. I'm not sure.
Okay. Well, it's the hypotenuse. Well, that it actually doesn't matter. We have a right triangle, and before SOHCAHTOA, the first thing we should think of with the right triangle is our good friend Pythagoras, the Pythagorean theorem, which is a squared plus b squared equals c squared. You remember?
Yeah.
Okay. And the reason I say that is we have two sides, and anytime you have two sides of a triangle, you can find the third side using the Pythagorean theorem, right?
Yeah.
Okay, so we can do that. We just have to figure out what goes with what. And the most important piece of the Pythagorean theorem is the C part, because the C part is always the hypotenuse.
Mm-hmm.
Is that right?
Yeah.
Okay. And is AC, is it the hypotenuse or one of the two legs?
AC is the hypotenuse.
Cool. So that's what we're looking for, right?
Yeah.
Okay. So instead of having to write C, maybe we could just throw in an X. It makes it a little bit easier. I don't know. And then we just plug away, right? 11
Yeah.
squared plus 5 squared equals X squared, and off we go. And we are riveted by this discovery. And we can go to the nearest tenth again.
Okay, yeah, that makes sense.
All good?
Yeah.
Cool. All right. So now angle A or angle C? You're the guest of
A.
honor. A?
Yeah.
Okay. So my rule of thumb is always use what they give you, just in case you made an error with whatever you find, right?
Yeah.
So for angle A, let's use the given sides, which are 5 and 11. So which trig function should we use?
Tangent.
Excellent. So what's the equation?
Tangent x is equal to 5/11.
Okay, I put A in there just because it's angle A. I know you meant that. And then how do we do how do we find an angle?
I think like it's something like to make it negative, and you like times it by itself or something.
We use the inverse tangent, the arc tangent. So A equals the arctan of, or the I'll say inverse, the inverse tangent of 5/11.
Yeah.
Does that sound familiar?
Yeah, that does.
Okay. So that goes back to what I was saying at the beginning. There's only one angle that has the tangent ratio of 5/11, and the calculator is calculating that for us. And yeah, your calculator is in degrees because you've been getting those right. So let me know what you get for the angle.
I got 24.4.
Excellent. All right, so I'll slap that in there, 24.4. And what do you want to do to find the measure of angle C?
For C,
Mhm.
we use opposite and adjacent.
Yep, because 12.1 is hypotenuse, right?
Yeah.
However, this is, I guess I'm going to make an exception to my rule here. I have two angles, don't I?
Yeah.
So I don't have to do the SOHCAHTOA if I don't want to. I can just subtract from 180,
Oh, yeah.
right? I mean, it's a little less stressful. I don't know,
Yeah.
right?
Yeah, it
So
is.
let's just do that. Measure of angle C. I ran out of room. I got 65.6.
Yeah. Same.
Cool. All right, and I'm just gonna have you think through one more thing here, and we'll stop because we're up to time. So we're in a right triangle, right?
Yeah.
And maybe you did this, so you can tell me if you did this. And so we know this guy right here is 90 degrees, correct?
Yeah, it is.
So there's only 90 degrees remaining, and for the other two angles, right?
Yeah.
So instead of subtracting 180 minus 90 minus 24, if we remember that there's only 90 degrees left, I can find angle C by just subtracting 24.4 from 90.
Yeah.
It's just one less thing, it's one less subtraction to do. if you think, if you realize it or if you see it. If not, whatever, it's not that big of a deal. But yeah. Okay, so did you find that helpful?
Yeah, that was really helpful.
Was it?
Yeah.
Okay, like it, because and I told your mom this, that if it's not, you have to you have to say, I don't want to waste your time, and you can tell her or whatever. No hard feelings. The main thing is for you to get whatever you need out of the session. Okay.
Yeah.
So is Saturdays are for the boys? Is that like a thing? Like, is that from a song or something, or is that a?
No, it's just like a saying
It's just the
for a
same.
while. Yeah.
Okay, I thought that I'm very hip. I'm very cool, Luke. So I like
Yeah.
to be up on the things, right? All right. Hey, listen, it was nice to meet you, and
Yeah. Nice to meet you too.
we will. I think we're going to meet again next week. We just have to work out the time. I have to look. I think it'll be the same time each week, but I'll let you know. Okay.
Okay.
I will send you the notes. I have your email, and
Yeah.
I will upload the video to my YouTube channel, but it's going to be in your own folder. Okay. And
Okay.
so I'll send you, because I know you want to rewatch this. I'm going to rewatch it immediately.
Yeah.
Um, uh, I will send you the link to the folder. So that way I don't have to send you the link to the video every time.
Okay.
If you bookmark that, then it's me and you talking for an hour. What's better than that, huh?
Yeah.
All right. Have a good one. See you in a week.
Yeah, you too. Thank you.
All right. You're welcome. See you, Luke.
Bye.